In our next section, we're going to look at how spanning tree interacts with the ACI, specifically when we're doing external bridge networks and we're extending the layer 2 network outside of the ACI. And as I mentioned before, the big point about this is that ACI itself does not run spanning tree, which means that you do have the potential for a loop if you misconfigure the network on the regular classical Ethernet end. But we'll see that it does tunnel the traffic over VXLAN on the back end. So continuing with our previous example where we had the 7Ks that had configured trunks up to the ACI leafs, we saw that we did have connectivity between our end-to-end applications. Like if we were to go to, let's say 5K1, and on 5K1 we look at the show IP interface brief. Okay, right now we don't have any layer 3 configured. We're going to configure an interface that is in VLAN 1002. IP address is 10.0.251/24, and we're going to do a default route to 10.0.2.254. Okay, we should be able to ping within our subnet, so 10.0.2.11 is one of the servers. We should be able to ping to the ACI leaf, which is the gateway of 10.0.2.254. And then we should be able to ping to other subnets based on our contracts that we have applied to the EPGs. Okay, so 10.0.1.73 is one of the destinations. Okay, let's look at now from a layer 2 point of view how specifically we're forwarding to get to this destination. So from 5K1, we want to know how are we mapping the IP address to the MAC address, because the MAC address is going to be used in the layer 2 frame once we're actually doing our bridging decision. So if we look at the show IP ARP, we see 10.0.2.254, which is the gateway, is mapping to 123.4.56789 which is what we had configured under the bridge domain under the subnet under the MAC address of the Anycast gateway. So from the APIC, when we're looking at the show run, we should see that this is configured under the interface bridge domain. And then under interface bridge domain, this is essentially going to be a static MAC address that is assigned on the interface. Okay, so it's this one here. 10.0.2.254 is mapping to 123.4.56789.0 Okay, from 5K1, let's trace this from a layer 2 point of view. So let's look at the show MAC address table for address this particular guy. And it says we're going on E16. Okay, if we show CDMA neighbors on interface E16, this is going physically towards 7K2. From 7K2, if we look at the same output, show MAC address table for that address, we're going out interface E18 or E17. Okay, E17, if we take a look at the diagram, this is going from 7K2 up to leaf 101. So in our particular network here, we have 4 physical links, so 2 from each of the 7Ks to each of the leafs. But if we look at this from a spanning tree point of view, show spanning tree for VLAN 1002, we're going to run into the same exact problem as we would in legacy classical Ethernet, that with multiple layer 2 paths, we're going to have to block all of the redundant ones. Okay, so again, even though that it's not directly participating in spanning tree, if we look at the interface level and look at the show spanning tree interface E18 detail, it says that on VLAN 1002, the root bridge identifier is 00DE, FB12, etc. Okay, so this is one of the 5Ks configured with a priority of 0. And it says the designated bridge has this particular address. Okay, if we look at the show spanning tree VLAN 1002 detail, and we look at our local bridge ID. Okay, local bridge ID is 0026.980C, etc. Okay, the 2142 address. And if we look at it, says who is the designated bridge on the interface. Notice what this value is our own local bridge ID. So essentially what's happening on port E18, if we look at the physical topology, is that a BPDU is going out this interface here. So spanning tree packet goes out, and it has a layer 2 multicast destination. Okay, the ACI leaf is going to locally switch this out the other port. So it's going to go down this direction towards 7K1. It's also going to get encapsulated inside of VXLAN, and it's going to forward over the multicast distribution tree on the fabric, go up to the spine down to the leaf. Leaf 102 is going to decapsulate this and then send this as a layer 2 multicast down in this direction. Or in other words, 7K2 is receiving its own BPDU back in. Now, luckily, it does have spanning tree enabled, so the end result is it says, hey, I need to block this interface because it's looping my own BPDU in, so it's a backup path in order to reach me. The end result is that out of these 4 interfaces where the 7Ks have connected to the leafs, only one of them is going to be used for active forwarding. And we can see this if we were to go to 7K1 and look at the show spanning tree for VLAN 1002. Both interfaces E17 and E18 are in the blocking state based on the normal spanning tree path selection. So if we look at the difference between 7K1 and 7K2 for show spanning tree for VLAN 1002, and we look at the bridge IDs, it says my local bridge ID is 0026980C2142. If we compare this to 7K1, we can see that 7K2 has the lower of the values. Okay, 0026 versus 68BD. The end result is that spanning tree is preferring the lower MAC address because there's a tie in the priority, which means that 7K2 is going to be the designated bridge. Or in other words, 7K2 is forwarding one of those interfaces towards the ACI. All of the other interfaces are going into the blocking state. Now, what would be the misconfiguration for this is that if you had a device that was not running spanning tree and you plugged it in redundantly to the leafs, you actually will cause a loop in the network. Okay, so let's say that we were to do a packet capture on one of these interfaces. Okay, let's say that this is going to be from server 1's point of view. Okay, and the way that we have, let me clean up the diagram here. The way that the network is currently set up is that 5K1 is the root of the spanning tree. Okay, for VLAN 1002. So server 1 is going to send an ARP, and let's say it's trying to resolve its gateway. So it goes up this direction. 5K1 is going to flood this in both directions towards the 7Ks. The 7K, as it stands now, would only flood this in one direction. When the frames come back in, they would be dropped because of spanning tree running in the blocking state. Okay, but let's say that we were to undo that. The way that we can undo this is basically to filter the spanning tree packets as they're going from the 7Ks to the leafs. Okay, so what I'm going to do in the meantime is go to the server, and I'm going to capture both ARP packets and ICMP packets. Okay, so let's say we were to ping our gateway, ping 10.02.254. Okay, we can see just echo and echo reply. If we were to delete the ARP cache and then ping again, we should see that we should also, let me search for just ARP. Let's say, and selected. So it's ARP and, no, I want to say and or selected. Okay, so let's say ICMP applies a filter, selected, and then maybe I just need to do it in quote or parentheses, or ARP. There we go. Okay, ICMP or ARP. Okay, so point being is that we have a single resolution request, single resolution response. Okay, there's no loop in the network. Delete the ARP cache, we should see that the server is going to re-ARP for the destination. Okay, so we broadcast the ARP. Who has that address? The gateway responds, say, hey, I'm 1234. Now it can ping between them. Okay, everything's fine. Okay, now we go to the 7Ks and we're going to turn spanning tree off. Okay, not necessarily turn it off globally, but we're going to turn it off at the port level. So what we're going to do here is to go to interface E1 7 to 8. We're going to shut the ports down first. Okay, on both switches. Shut. Then we're going to filter out spanning tree. We'll say spanning tree, BPDU, filter, enable. And spanning tree port type is edge trunk. Show run interface E1 7 to 8. Okay, so we're filtering in both directions, or on both interfaces, BPDU filter enable, and on 7K2. Okay, then we no shut the link. Okay, now from the end host point of view, we delete the ARP cache, ping to the destination, and it actually hangs there because if we go to the 7Ks, let me shut the ports down again. What happened here is we caused a layer 1 loop. Okay, so you can see thousands of ARP frames going through. So point of this is turning spanning tree is not the solution. Turning spanning tree off is not the solution, right? Okay, so even though the ACI is not running spanning tree, it is bridging it across. It's tunneling it from port to port. So you would need to treat this as essentially a regular layer 2 switch. It's just that your own spanning tree packet goes out and then comes back in. So if we wanted to do forwarding across all of the interfaces at the same time, we need to treat it like it's one logical link from a spanning tree point of view. So in this type of design where you have your classical Ethernet network that is attaching to the leafs, what you would typically want to do is configure this as a back-to-back VPC. So on the 7Ks, I already have the VPC domain set up. So 7K1, 7K2 are the peers. I have the peer link as the east-west connection, the port channel between them, and then the keep alive as the management interface. Okay, what we're going to do is say that interfaces 7 to 8 on both of the switches. These are going to be trunk ports, and these are going to be VPC members. The difference is now going to be on the ACI config. We're going to configure all of those 4 interfaces as one single virtual port channel, and then apply this as the layer 2 external domain, which is essentially the trunk link that's going to the external endpoint groups. Okay, the EPG that we have for VLAN 1002 and for VLAN 1003. So from the 7K config point of view, there's nothing special, same as just a normal VPC. So on both of these switches, let's say default interface E1 7 to 8. Okay, if we look at the show VPC, we see the peer adjacency is foreign, peer is alive. Okay, the peer link is up. We're forwarding VLANs 1002, 1003. Those are the VLANs that we're trying to forward out the members. Okay, then we're going to use port channel 1 as our member port. So on interface E1 7 to 8, we'll say channel group. We can type it, channel group 1 mode active. Okay, that's assuming that we have LACP feature enabled. Then on port channel 1, this is going to be a switch port. The switch port mode is trunk, and this is VPC 1. No shut. Okay, same thing on the physical ports. Then let's enable logging, terminal monitor. If we show port channel summary, port channel 7 and 8 currently down. Okay, it says the port channel is suspended because no LACP protocol data units being received. What this basically means is that the interface policy group that is applied on the ACI side is not configured for a channel. It's configured for regular independent trunk links. Now from the 7K side, since we have the command LACP suspend individual, end result is that the ports are going down as opposed to going into independent state or individual state. Okay, end result of this means that if we go to ping the traffic through the fabric, okay, they ping the gateway, we can see the frames are getting dropped. Okay, because LACP is blocking the interface. What we need to now do is to modify the fabric access policy config so that we're forming a VPC, and it's going to be between all 4 interfaces that are on the leafs. Okay, all 4 interfaces that are going to 7K1 and 7K2, I should say. Okay, specifically, it's going to be leaf 101, port 11 and 12, and then leaf 102, port 11 and 12. Okay, so from the GUI, what we're first going to do is to remove the previous fabric access policy that we have configured. So we're going to go under Fabric, Access Policies, okay, Fabric Access Policies, and then configure an interface, port channel, and virtual port channel. Okay, so right now we have a switch profile that is for leafs 101 and 102. So we're going to go to interface 1, to 2, and we're going to delete these. Okay, notice it says that right now the port type is individual. What we're trying to change that to is port type is VPC. So yes, we want to delete it, and then we want to submit. Okay, it says, do you want to delete these objects? Yes. Okay, so we're going to do the same thing under Quick Start. We're going to go to Configure an Interface, Port Channel, Virtual Port Channel. We need to configure the VPC switch pair. Okay, this is the VPC domain. So we'll choose domain number 1. It's leafs 101 and 102. Save. And submit. Okay, so that's creating the VPC domain. If we now go to the CLI of the APIC, from the APIC, we're going to drop to the bash shell, then attach to leaf 101, log in, and show VPC. So same type of output as we see on the 5Ks or 7Ks. Says we have the pure adjacency, formed fine. Okay, the pure keep alive doesn't apply to the ACI implementation, but from a cosmetic point of view, it's the same output as we would see on the regular Nexus code. And it says VPC1 is the peer link. Okay, it's up, but we don't see the specifics of whatever the VLANs that it is forwarding. Okay, and remember, in the physical topology of ACI, it's always leaf, spine, leaf. You do not connect the leafs together in order to form virtual port channel. It's doing that automatically through the fabric. So over the spines, as long as you have reachability to any of the spines, then it means you have routing reachability to the leafs because of ISIS in the infrastructure fabric underlay. Okay, now we're going to configure the physical ports. So we're going to go under Fabric Access Policies, Quick Start, Configure, Interface Port Channel, and Virtual Port Channel. Okay, we already have a profile, a switch profile, that is for both for switches 101 to 102. So we're going to configure the interfaces on them, and this is going to be a VPC. Okay, the VPC specifically is made up of 101, 101 to 2, and 102, 11 to 2. So it's 4 interfaces. We're going to call this interface selector name, which is leaf 101 to 102. And then we need to create a new interface policy group. Okay, in this case, we cannot use the previous one that we had called the access ports policy because the interface policy group is applied uniquely to an individual port channel or an individual virtual port channel. Okay, it's basically the way that we're binding the port channel number to the link. Now, we can call the same policies, though. So we could say the interface policy group is calling the CDP policy CDP on, and we're going to call a port channel policy that's going to run LACP. Okay, so we'll say that this port channel policy is LACP active. And the mode is going to be LACP active. Okay, minimum number of links is 1. We have a suspend individual. Okay, basically the same options as we have in standalone NXOS. Then attached device type is going to be our external bridge device. So we already have this created. We don't need to go through this setup again. We're just going to choose that we have the domain. This is going to be the trunk to the 7Ks. So since we already have the endpoint group deployed on the external bridge networks, the only thing essentially that we need to do is to make sure that that is applied to the VPC once the interface is created, and then we should be able to regain connectivity through the fabric using whatever the previous contracts that we had defined are. Okay, so under Leaf 101 and 102, we have ports 11 to 12, and the interface type is VPC as opposed to individual. So save the config and submit. Okay, what we should now see is that from the 7Ks, we get a log message that the links are flapping and that LACP should negotiate them into the channel. So let's look at the show port channel summary. Okay, the exact same output as we would see on the 7Ks is what we would see on the ACI Leaf. Okay, it is lowercase though, show port channel summary. Okay, so on 7K1, let's say show run interface port channel 1 membership. We're going to copy and paste this config to the other 7K. Okay, so it's identical config for the member ports. Okay, if we look at the show port channel summary, ports are up. Okay, if we look at the show VPC, we have member port channel 101, which is forwarding VLANs 1002 to 1003. Okay, same thing should be true on the other member, show VPC. VLANs 1002, 1003 are forwarding. Same thing should be true from the ACI Leafs. Show VPC. It's choosing VPC number 685 automatically. It shows port channel number 8 automatically. But key point is that the status is up. Okay, if we look at the show VLAN extended, we should also see that our bridge domains are now going to be assigned to that particular port channel. Okay, this is going to be the step that is missing from the config. So previously under the tenant networking for the external bridge domains, we had the EPG applied to the physical port. Now since we have deleted the object which is the physical port and replaced it with the virtual port channel, we now need to go redeploy the EPGs. So the way that we do this is we're going to go under tenants, tenant INE, networking, external bridge networks, whatever the layer 2 out is called, whatever the EPG is called, and then we're going to, actually no, not the EPG, just the L2 out. So external bridge networks and then the L2 out name, and then we're going to add, we're going to delete the previous ones, okay, deleting the previous physical ports, and the path type is now going to be VPC. Okay, path option is going to be Leaf 101 to 102, ports 11 to 12. Okay, the policy group that it created. Okay, same is going to be true with VLAN 1003. So we're deleting the physical ports and then replacing this with the VPC. So add it and then submit. Okay, if we look back at the Leaf now and look at the show VLAN extended, what we should now see is that now the bridge domain is applied to the port channel. Okay, which previously the bridge domain did exist, but it wasn't actually applied on those links. Okay, now let's look at the traffic flow. So if we go to our end server, we ping to the gateway. Okay, we can reach the gateway. Let's say we now go to web browse through the fabric. Okay, we have a contract already that is allowing HTTPS through. So we'll HTTPS to 10.0173. Okay, we can reach it. Okay, let's look at how specifically we are reaching this. So if we look at the ARP-A, we're ARPing for our gateway, which is 10.02.254, MAC address of 12345678990AB. This box is physically, this server is physically connected to 5K1. So from 5K1, we look at the MAC address table. Okay, show MAC address table for VLAN 1002. Okay, we have that particular destination. It's located at port E16. If we show CDP neighbors on interface E16, this is going to 7K2. From 7K2, if we show MAC address table for that address, we see this is now reachable over the member port channel. Okay, same should be true from the ACI leafs. So if we look at from the end server's point of view, the server's MAC address, if we look at the get MAC, okay, server's MAC address is all zeros 111. Okay, this is what I had statically set on the adapter. If we go to the leaf and look at the show MAC address table, we see that on port channel 8, which is the member port channel, we're learning all zeros 111. Okay, notice that I didn't say show MAC address table VLAN 1002. The reason why is that VLAN 1002 is not the one that the leaf is provisioning on the back end. Okay, it's choosing again some pseudo-random number from its pool. That VLAN 26, from an encapsulation point of view on the port channel locally, is being encapsulated as 1002, but from the forwarding table point of view, the bridge domain, it's choosing some other essentially random number. Okay, we could see the mappings for these again if we look at the show VLAN extended. That VLAN 1002 is really mapping to VLAN 26. So if we show MAC address table for VLAN 26, those are going to be our forwarding entries. Okay, the other potential thing that we would need to do with spanning tree is if on the layer 2 out we're running multiple spanning tree as opposed to rapid spanning tree. So on the 7Ks in this case, we can tell the ACI that if there is a convergence event and you need to flush out the MAC address table of the leafs, what other bridge domain should you also flush out based on the mappings of the VLANs to the multiple spanning tree instances. So it's basically an optimization or reconvergence that if there's a flap on the 7Ks, that should also affect the CAM table or the MAC address table of the leafs for anything that is part of that spanning tree instance. So this is defined under the switch policy under the Fabric access policies. So Fabric access policies, then under switch policies, spanning tree, then this is where you would define what are the region and VLAN instances. Okay, so MSD instance number 1 is encapsulations from VLAN, whatever, 1 through 100. So then what this is saying is that if there's a convergence event on a link that's in VLAN 50, you need to flush out the MAC address table of VLANs 1 through 100 because those are all part of the same multiple spanning tree instance on the classical Ethernet end. But again, it doesn't mean that the ACI is actually running MST itself. It's just a matching of the convergence optimization where rapid spanning tree flushes out the CAM table. It's making sure that the leafs also do this as well.